We have an anchor, a human rhythm. The tick of a clock, the rising of the sun, the turn of the seasons. Our lives are measured in these small, digestible loops. We think a lifetime is long. We think a civilization that lasts 1,000 years is ancient. But this human-centric metronome is a profound, comforting lie. It blinds us to the abyss we are floating over. Let's speed up that clock. Faster. Watch the hands blur. Suddenly, the Roman Empire isn't an empire. It's a flash. The pyramids at Giza don't rise. They simply appear and begin to erode in the same instant. Every war we ever fought, every god we ever prayed to, every line of poetry ever written, all of it flashes by in a single, chaotic, indivisible moment. This is the timescale of our civilization. Now speed it up again. Our entire species, Homo sapiens, intelligent, self-aware, masters of the world, has walked this planet for perhaps 300,000 years. It's an impressive number until you place it against the backdrop of the Earth itself. 4.5 billion years. Let's use that old analogy, the 24-hour clock. If Earth was formed at midnight, the first simple-celled life appears by 4 a.m. But complex animals? They don't arrive until 8:30 p.m. The dinosaurs rule the world for over an hour, from 10:40 p.m. until just before 11:40 p.m. And humanity, Homo sapiens, we appear at 2 seconds to midnight. Everything we have ever known, every ancestor, every city, every kingdom, every idea, is confined to that last, frantic tick. This simple fact leads to the most profound, and perhaps most arrogant, assumption we've ever made. We assume the clock started with us. We look back at the 99.99% of Earth's history that came before, and we see only a prologue. A long, empty stage being set for our arrival. We see fossils of strange beasts and forests of giant ferns, but we see no one. Like us, we are obsessed with the idea of aliens. We search the heavens for a signal from another intelligence, a sign that someone, something, is out there. It's a core human desire to know we are not alone. But in our quest to look outward into the billions of light-years of space, we have almost completely ignored the billions of years of time right here at home. What if the real aliens weren't from Zeta Reticuli? What if they were from the Silurian period? Forget what you think you know about ancient. We are not asking if a lost human civilization existed 10,000 years ago, hidden in the fog of our own ice age. We are not even asking about the time of Tyrannosaurus Rex. We are pushing further back. We are pushing into a time so alien it may as well be another planet. A time before the continents had their familiar shapes. A time before the first dinosaurs. We are talking about the Devonian 400 million years ago. Imagine a world of sprawling, humid forests of 50-meter-tall fungi and giant ferns. A world where dragonflies had the wingspan of an eagle and the air was so thick with oxygen that fire itself behaved differently. This world lasted for tens of millions of years, an unimaginable span. Is it not possible in all that time that another intelligence looked up at the same sun? That a different kind of mind, evolved from a different lineage, built a different kind of world? This is the question at the heart of our investigation. It's an impossible one. The Earth itself seems to guard this secret. The planet is a machine for recycling itself. The forces of erosion, subduction, and metamorphism have crushed, melted, and remade the world many times over since then. The immediate, logical, and scientific answer is no. Of course not. Because where are the ruins? Where are the bones? But that is the easy answer. The hard question, the one we're going to ask, is, what if we've been looking for the wrong evidence all along? So, the first question, the obvious one, is where is it? If an industrial civilization rose and fell 400 million years ago, where are its ruins? Where is its Mount Rushmore, its buried skyscrapers, its radioactive landfills? It's a fair question, and the answer is geology's greatest, most terrible secret. The Earth isn't a museum. It's a furnace. It doesn't preserve its past. It systematically, relentlessly destroys it. Consider the ground beneath your feet. It feels solid, permanent. It is not. The continents are thin, fragile rafts floating on a sea of molten rock. And the ocean floor, the place where most civilizations would build, is a temporary crust on a massive, slow-boiling conveyor belt. Through a process called subduction, this entire ocean floor is being dragged back down into the Earth's mantle, where it is melted, annihilated, and erased from history. The average age of the ocean floor today is only about 100 million years. Anything from 400 million years ago, it is gone, not just buried, melted. But surely you might think the continents are safer. Not really. In the 400 million years since the Devonian, the continents have drifted, collided, and torn themselves apart multiple times. The Appalachian Mountains, for example, were once part of a range taller than the Himalayas, formed when ancient North America crashed into an ancient Africa. Any Silurian New York, built on that coastline, would have been either subducted into the mantle or crushed into a mountain range. It wouldn't just be a ruin, it would be a vein of quartz in a mountain, which itself would later be ground to dust. Let's say, by some miracle, a fragment of their world survived this tectonic recycling. It finds itself on a stable piece of continent. Now it faces its second great enemy, erosion. For 100 million years is not just a long time. It is an eternity for wind, rain, and ice. We think our structures are permanent. The Great Pyramid of Giza has stood for 4,500 years, and it is already visibly weathered. Now, multiply that span of time by 100,000. Mountains are born and scoured to dust in that time. Canyons deeper than the Grand Canyon are carved and then filled in. A steel skyscraper would oxidize into a pile of rust and vanish in a few thousand years. A glass window would be shattered and ground back into simple, indistinguishable sand. Even our strongest concrete would be pulverized. The only things that survive this long are fossils, and that's because they undergo a very specific, very rare process. A bone or a shell has to be buried in the exact right sediment, at the exact right time without oxygen to be slowly replaced by minerals. It's an almost impossible lottery. But even if an artifact won this geological lottery, it faces a final executioner: metamorphism. As layers of sediment build up, mile after mile, the pressure and heat become immense. This cooking process bends, folds, and crystallizes the rock. A delicate fossilized bone, or the perfect impression of a Silurian microchip, would be stretched, crushed, and distorted. It would become nothing more than a meaningless graphite smear in a slab of gneiss. It ceases to be a fossil. It just becomes rock. So, this is the great filter of deep time. Tectonics melts the board. Erosion scours the pieces, and metamorphism crushes whatever is left. The Earth is a hard drive that is constantly, violently formatting itself. To look for a city, a statue, or a tool is to look for a specific grain of sand on a beach that has been melted into glass, shattered, and reformed 1,000 times over. The physical evidence is gone. The case is, for all intents and purposes, closed. And yet, this complete and total erasure is what makes the question so fascinating. The quest seems impossible. We cannot look for a Silurian New York. We cannot look for artifacts. But what if we've been looking for the wrong thing entirely? What if an industrial civilization doesn't leave a legacy of things, but a legacy of change? You can't find a 400-million-year-old plastic bottle. But you might be able to find the chemical echo of the billion tons of plastic they manufactured. We have to stop looking for a needle in the haystack and start looking for the chemical shadow of the entire haystack, burned to the ground. So, the Earth's geology has erased all the evidence. Any building, any city, anything an ancient civilization might have left is gone, melted and crushed back into the planet. This is where the investigation should end. It's a dead end, a fascinating idea with no possible proof. But in 2018, two scientists, an astrophysicist named Adam Frank and a climatologist named Gavin Schmidt, asked a different, more intelligent question. They asked, what if an industrial civilization doesn't leave behind a statue? What if it leaves behind a scar? This is the Silurian hypothesis. The name is a nod to an old Doctor Who episode, but the science is deadly serious. The hypothesis is simple. The most enduring legacy of an industrial species isn't its cities, but it's pollution. It's a footprint, a chemical fingerprint pressed into the planet's own geological record. Frank and Schmidt realized that if we are to look for them, we must first understand ourselves and the footprint we are leaving right now in this very moment. Look at our world. We are in the middle of our own industrial revolution. We have been burning fossil fuels at an exponential rate for 2 centuries. We are, in effect, digging up carbon that life painstakingly buried over hundreds of millions of years and releasing it into the atmosphere all at once. This isn't just changing the climate, it's changing the chemistry of the planet. This global scale change is our true, lasting monument. This is the Anthropocene, the age of humans. This gives us our first target. If a civilization of Silurians had their own industrial revolution, they almost certainly would have powered it the same way, by burning their own ancient buried carbon. If they did, they would have left the exact same signal we are leaving. Buried deep in the rock strata from 400 million years ago, we should be able to find a sudden, massive spike in carbon dioxide. We would find the chemical signature of a global warming event. We would, in essence, find their climate change. But we can go deeper. What else are we leaving behind? Our oceans are slowly filling with microplastics. These synthetic polymers, these forever chemicals, are things nature cannot create. They are entirely artificial. Finding a single, complex molecule of polyethylene in a Devonian-era rock layer would be more conclusive than finding a pyramid. It would be a technosignature, a chemical artifact that has no business existing naturally. It would be the proof. And then there is our most terrible invention, our mastery of the atom. Widespread use of nuclear power, or worse, a nuclear conflict, leaves an unmistakable radioactive fingerprint. It creates isotopes like plutonium-244 that do not exist on Earth naturally. These particles would be cast into the atmosphere and settle into a single, thin, global layer of dust. That layer would be preserved in the sediment. A 400-million-year-old layer of plutonium? That is not a geological event. That is a civilization's tombstone. This is the Silurian hypothesis. It transforms the quest. We are no longer archaeologists wandering in the dark. We are forensic chemists with a list of specific testable clues. We don't need to find a ruin. We need to find the chemical echo of the civilization that built it. We must hunt for a sudden change in carbon, a molecule that shouldn't exist, or the faint radioactive pulse of a long-dead technology. The hunt now has a map. The impossible investigation can begin. So we have our list of targets. We are no longer archaeologists digging in the dust for a broken pot. We are forensic chemists drilling into the deep, frozen memory of the planet itself. The hunt for these geochemical ghosts takes us to the most remote places on Earth. We travel, visually, to the blinding white expanse of the Antarctic Plateau, and to the crushing, absolute darkness of the deep ocean floor. This is where the planet keeps its most pristine libraries. These libraries are not made of paper. They are long, perfect cylinders of ice and mud, pulled from miles beneath the surface. Trapped within the ice cores are tiny, ancient bubbles, actual, physical samples of Earth's atmosphere from 1 million years ago. The deep-sea sediment cores contain the microscopic shells of plankton, whose very chemistry is a thermometer, recording the temperature and acidity of the ocean they died in. Each layer is a page. Reading them is like reading the Earth's autobiography. And this autobiography is not a peaceful story. As we scan these layers, we find the planet's climate is not stable. It is a chaotic, violent system prone to wild swings. The Earth has been a snowball, frozen solid. It has been a hothouse, with palm trees at the poles. The record is full of spikes, drops, and oscillations. Our search just became infinitely harder. We aren't looking for a single climate event. We're looking for one that looks artificial. A spike that looks like us. We start with the most violent chapters, the mass extinctions. We all know the one that killed the dinosaurs 66 million years ago. But that was not the worst. Not by a long shot. We go back further to 252 million years ago, to the boundary of the Permian and Triassic periods. This event isn't called an extinction. It's called the Great Dying. It was an apocalypse. Over 90% of all species in the ocean and 70% of all life on land was simply erased. It's the closest life has ever come to a total planetary sterilization. And what was the killer? When we look at the chemical fingerprint in the rock, the blood runs cold. The culprit was a massive, sudden injection of carbon dioxide into the atmosphere, leading to runaway global warming and oceans turning to acid. Does that sound familiar? It is the exact scenario we are creating right now. The scientific consensus points to a natural smoking gun. The Siberian traps, a colossal, continent-sized volcanic eruption that bled magma and $EXTCO_2 for nearly a million years. This is the official story. The case is closed. But in our investigation, we have to ask the hard question. Is the timing too perfect? The Great Dying happened with terrifying speed, perhaps faster than the volcanoes alone can explain. What if the Siberian traps are a geological alibi? A convenient natural catastrophe that masks another, underlying cause? What if an industrial civilization had already pushed the planet's climate to the absolute brink, and the volcanoes were just the final, terrible push over the edge? The evidence is circumstantial, but the correlation is chilling. The Great Dying is a powerful suspect, but it's not the only one. We move forward in time to 56 million years ago. Here we find another ghost, the Paleocene-Eocene thermal maximum, or PTM. In the geological blink of an eye, the entire planet's temperature rocketed upwards by 5 to 8 degrees Celsius. The poles melted. The oceans acidified. It was a global fever that lasted for over 100,000 years. And the cause? A massive, mysterious injection of carbon into the atmosphere. This one is even more baffling. There is no Siberian traps to blame. Scientists still fiercely debate where all this carbon came from, suggesting everything from methane hydrates to burning peatlands. The fact is, nobody knows for sure. The PTM event is, perhaps, the single closest analog in all of Earth's history to our current industrial emissions. We are chasing the chemical shadow of a civilization, and here, we find a 56-million-year-old event that doesn't just look like a civilization's footprint. It looks identical to our own. We have hunted the ghosts. We found tantalizing, terrifying echoes in the deep past. We found the Great Dying, an apocalypse of carbon and acid that looks chillingly familiar. We found the PTM, a rapid-fire global warming event 56 million years ago that mirrors our own industrial footprint. The correlation is undeniable. The Earth has seen this before. Feels like we are on the verge of a revelation. And yet, this is where the investigation takes its final, sober turn. For every tantalizing anomaly, science provides a powerful, natural explanation. We must, as objective investigators, look at the evidence as it is, not as we wish it to be. And the first, hardest piece of evidence concerns the carbon itself. When we burn fossil fuels, ancient buried life, we release carbon with a very specific chemical fingerprint, a unique ratio of isotopes. Volcanic carbon, released from the Earth's mantle, has a different fingerprint. When scientists analyze the carbon from the PTM and the Great Dying, the signature they find is overwhelmingly, conclusively volcanic. Then there is the question of speed. Our current industrial spike is a true geological absurdity. We are releasing carbon at a rate 10 times faster than even the most violent moments of the PTM. What looked like a sudden spike in the deep past was still, by our standards, a slow burn. The Earth, it seems, has never experienced a shock to its system as rapid and violent as us. We are, in this terrible way, unique. The ancient fevers were natural illnesses. Ours is a self-inflicted wound. But this wasn't our only target. We were also looking for the forbidden molecules, the complex synthetic polymers, ancient plastics that nature cannot create. This would be the definitive technosignature. Geochemists have scoured these ancient rock layers. They have searched for the unnatural, the artificial, the signature of a mind. And the verdict is unanimous. There is nothing. No forever chemicals in the Devonian. No synthetic tracers in the Permian. The strata are chemically, profoundly natural. Finally, we come to the most unambiguous smoking gun of all. The atom. A nuclear war, or even widespread industrial nuclear power, would have left a thin, global layer of specific radioactive isotopes, like plutonium-244 or curium-247. These elements do not exist on our planet naturally. Finding them in a 400-million-year-old rock layer would be undeniable proof. It would be the tombstone we were looking for, and the search has yielded absolute silence. The silence of the strata is overwhelming. Nature, it's true, is capable of the extraordinary. In Gabon, Africa, there is a 2-billion-year-old formation known as the Oklo mine. It is undeniably a natural nuclear fission reactor. The planet itself achieved criticality and ran a controlled nuclear reaction for hundreds of thousands of years. But the key is we know it's natural. Its isotopic waste looks different from our own. We can tell the difference. And the rocks from our target periods show nothing. No Oklo, no Chernobyl, no Silurians. The hunt is over. The case is, for now, closed. Every ghost we've chased has resolved into a natural force. Every echo, a feature of the planet's own violent life. The evidence is not there. We've looked for a predecessor, a forerunner, another mind in the abyss of deep time. The geological record has given us its answer. The silence is profound. The stage was not set. It was empty. It appears with an almost terrifying certainty that we are the first. So the hunt is over. We have drilled into the ice, scoured the ancient seabeds, and sifted the chemical dust of eons. We looked for a predecessor in the abyss of deep time, a fellow traveler, and we found nothing. The strata are silent. The geochemical ghosts we chased, the carbon spikes and thermal events, all resolved into the planet's own violent natural cycles. The long 400-million-year-old stage was, it seems, utterly empty. There was no one here before us. This conclusion feels hollow, almost disappointing. But this is precisely where our investigation truly begins. Because the entire time we were never just looking for them. We were looking for a mirror. The Silurian hypothesis, even in its failure, has given us the most profound and unsettling gift: an outside perspective. It has forced us to step outside our own time, to look at our civilization not on a human timescale, but on a geological one. We are the thing we were looking for. We are the anomaly. We are the planet's first experiment in high-energy, industrial, self-aware intelligence. We are the Silurians for the next civilization, should one ever arise in the eons after our extinction. We are, right now, creating the exact scar we were hunting for in the past. We are obsessed with our legacy. We build monuments of bronze and granite, believing they are timeless. We write symphonies, we paint masterpieces, we launch golden records into space, all in the desperate hope that some fragment of us will endure. We think of our glory, our empires, our complex philosophies, our art, our love. We carve our faces into mountains. We believe with a deep arrogance that these things define us. We imagine some future archaeologist sifting through the dust and understanding who we were. But the great filter of deep time, the furnace of geology we explored, tells us the brutal truth. In 100 million years, a mere fraction of the time we've been looking back, it will all be gone. Every city, melted and folded into a future mountain range. Every statue, scoured to dust. Every book, every digital file, every bite of our collective knowledge will have been erased by the relentless recycling of the planet's crust. The Earth will not preserve our glory. It will not remember our languages. It will not even know our name. All of it will be gone, except for the scar. The only thing that will prove Homo sapiens ever existed is that one, thin, anomalous layer of rock we are laying down globally right now. Our true, lasting monument is not our art. It's our waste. It will be the sudden, violent spike of unnatural carbon isotopes, a fever in the strata. It will be the global layer of synthetic polymers, our microplastics, a chemical that nature never invented. It will be the forever chemicals and the faint, unmistakable radioactive signature of our bombs and power plants. This is our true legacy. We set out on this journey to find the ghosts of a long-dead civilization. But the mirror has turned on us, and we see the truth. We are the ones who will haunt this planet. our chemical shadow, our layer of pollution will be all that is left. We are the anomaly that future geologists, if any ever exist, will puzzle over. They will find our thin, toxic layer and wonder, just as we did, what kind of intelligence could have done this? What kind of species, in its fleeting moment of brilliance, would mark its one and only home with a signature of such profound, global self-destruction? The silence of the deep past is not an absence. It is a warning. It is the sound of a planet that has never, in its 4.5 billion-year history, experienced an US. We looked for a predecessor to see how their story ended, to see if there was a lesson or a blueprint for survival. We found nothing, and in that terrifying, empty silence, we find that the pen is in our hands. The story is not a prequel. It is the original, and we are writing it now. We are the first. And the question the universe is now asking is if we will also be the last.